Oceanic crust is the part of Earth's lithosphere that surfaces in the ocean basins. Oceanic crust is primarily composed of mafic rocks, or sima, which is rich in iron and magnesium. It is thinner than continental crust, or sial, generally less than 10 km thick. However, it is denser, having a mean density of about 2.9 grams per cubic centimeter as opposed to continental crust, which has a density of about 2.7 grams per cubic centimeter. Composition. Although a complete section of oceanic crust has not yet been drilled, geologists have several pieces of evidence that help them understand the ocean floor. Estimations of composition are based on analyses of ophiolites, comparisons of the seismic structure of the oceanic crust with laboratory determinations of seismic velocities in known rock types, and samples recovered from the ocean floor by submersibles, dredging and drilling. Oceanic crust is significantly simpler than continental crust and generally can be divided in 3 layers. Layer 1 is on an average 0.4 km thick. It consists of unconsolidated or semi-consolidated sediments, usually thin or even not present near the mid-ocean ridges but thickens farther away from the ridge. Near the continental margins, sediment is terrigenous, meaning derived from the land, unlike deep-sea sediments which are made of tiny shells of marine organisms, usually calcareous and siliceous, or it can be made of volcanic ash and terrigenous sediments transported by turbidity currents. Layer 2 could be divided into 2 parts. Layer 2A, a (0.5 km thick uppermost volcanic layer of glassy to finely crystalline basalt usually in the form of pillow basalt, and Layer 2B, a 1.5 km thick layer composed of diabase dikes. Layer 3 is formed by slow cooling of magma beneath the surface and consists of coarse-grained gabbros and cumulate ultramafic rocks. It constitutes over 2/3 of oceanic crust volume with almost 5 km thickness. Geochemistry The most voluminous volcanic rocks of the ocean floor are the mid-oceanic ridge basalts, which are derived from low-potassium thalliatic magmas. These rocks have low concentrations of large ion lithophile elements, light rare earth elements, volatile elements and other highly incompatible elements. There can be found basalts enriched with incompatible elements, but they are rare and associated with mid-ocean ridge hotspots such as surroundings of Galapagos Islands, the Azores and Iceland. Life cycle Oceanic crust is continuously being created at mid-ocean ridges. As plates diverge at these ridges, magma rises into the upper mantle and crust. As it moves away from the ridge, the lithosphere becomes cooler and denser, and sediment gradually builds on top of it. The youngest oceanic lithosphere is at the oceanic ridges, and it gets progressively older away from the ridges. As the mantle rises it cools and melts, as the pressure decreases and it crosses the solidos. The amount of melt produced depends only on the temperature of the mantle as it rises. Hence most oceanic crust is the same thickness. Very slow spreading ridges,